Hello, F Sharp. Welcome back. We are continuing our journey of exploring the features of the F Sharp language. Today, we're going to talk about something that is very exciting, which is functions. Now, functions are such a core thing to the F Sharp language, and this comes from F Sharp's roots as a functional programming language. Now, let me clarify something up front. F Sharp is, how to say this? F Sharp has functional features, but I would not call it a functional language. If you want to call F Sharp a functional language, then you need to call C Sharp a functional language. You need to call Java a functional language. Heck, you might even need to call C a functional language if that's how you define functional. So what I like to say is F Sharp is a multi-paradigm language that has functional features. Now, F Sharp makes working with functions very easy, which is why I like it. My background as a chemical engineer, I thought a lot in terms of functions because as I was doing the math for a distillation column, it was just like function, calculate, result, function, calculate, result, function, calculate, result. And so when I got to F Sharp, like I've seen this before, except it was on an engineering pad at 2 a.m. So that's why it was a very natural language for me to think in because it was the first programming language I came across like, this is how my mind thinks. So functions in F Sharp. Up to this point, we've basically just been talking about types, things like records, things like discriminated unions, structs. So now we're going to talk about transformations of those types. And let us start with the most basic function of all. I am going to call this function my function. It's going to take two parameters, A and B, and then I'm going to say, hey, it's A plus B. Now let's unpack what is going on here. So let is the key word to say like, hey, I am declaring a thing. I am binding a name to something. My function is the name of the function. And the reason F Sharp knows this is a function is because my function is then immediately followed by two parameters, then the equal sign. You could also have a function which just takes a single value. So this is perhaps the most simple function. Hey, my function, it takes an A and it returns an A. And you can see here that Ionide is telling us like, hey, the type of this function is that it takes in a value of type A and returns a value of type A. We made it a little bit more advanced by saying we got a B and it's going to return a plus B. So we now have a function. And what's great in F Sharp is you can just define functions all you want. They do not have to be attached to a class. In a future video, we will go into the details about how F Sharp maps all this down to IL, so the language of the .NET runtime. That is not today, so don't worry about it. So we've defined an F Sharp function. F Sharp functions are special in that F Sharp makes working with them very easy. What we see now, though, is that type inference is doing something for us. It's saying, oh, hey, I see that you have A and B, and then you're doing something with it, and you're doing it in addition. And so now what type inference is doing is it's saying, hey, I see addition. What type am I aware of that supports addition? And in this case, it is an integer. So F Sharp is defaulting to say like, hey, I see you're doing addition here, therefore A and B must be integers. Now, in the future, we will talk about a feature which is inlining, but that is not for today. But I'm just going to say like it's out there, but that is going to be a talk farther out. So if you come across this, don't worry, we will get to that. It's in a future episode. So right now, type inference is saying like, hey, you're taking an integer, another integer, and you're returning an integer. Now, type inference is doing a lot of lifting here for us. That is fantastic. But let's say like, hey, you know what? I don't want, this isn't an integer, and I'm going to go ahead and zoom in since we got the space. I want this to be with floats. So then what we could do is I'm going to put a parentheses around this A, and then I'm going to use a colon after the A and say, like, you know what, this is actually a float. And now type inference is saying, oh, okay, A is a float. You're adding something to A. Therefore, B must also be a float, because that's how I understand addition to work. And so what's nice is I don't actually have to put the type on the B as well, although I can. And typically when I write code, if I kind of strictly define the type on one of the parameters to the function, I will often do it for all of them because I have something very particular in mind I am wanting that function to do. So bear that in mind. That's just a stylistic preference of mine. You do not have to do it. Also note that the compiler is inferring the return type. It's saying, hey, you're giving me a float, another float, and I'm returning a float. We don't have to tell the compiler what the return type is. It's inferring it. I'm actually going to go ahead and put this on a new line just to give us a little bit more space. But if I wanted to strictly define it, I could put float here. And this is saying, hey, dear compiler, I intend for this function to return a float. You don't have to do this. Most of the time, you don't have to do it. I will only do it if I have a very clear idea in mind of what I'm wanting that function to perform. And it's usually, I'm doing a lot of things. It's complex. And so like, I know at the end of this, I want it to return a thingamabopper. So I will say, hey, compiler, I want this function to return this type. So make sure that all of my branches of this function are returning this type. But you rarely need to do this. And it is, I don't see it done much. So don't be surprised if you don't see it. So, okay, we've defined this function. And what's great is F# has the ability to use partially applied functions. So if I wanted to take this function and fill in one of the parameters, I could do that. So I'm going to say my add 1. And I said, hey, that is equal to my function, and I'm going to fill in one of the values. And so what is happening now is the compiler is saying, okay, you're defining this new thing, my add 1. And what it is equal to is my function, except you filled in one of the parameters. And so my add 1 is now a new function that takes a float and returns a float. And so we are going to, let's go ahead and run this. I'm going to go ahead and run this whole thing because it's easier to, everything makes more sense when you actually see the code run. So I've defined these functions. I've defined my function, and I'm going to go ahead and put some values in there so you can see the results. So my function 1.0, 2.0, and go ahead and highlight and run it. And the result of my function is 3.0. Makes sense. I am now defining my add 1. So what it did is it took my function and it filled in the value for A. But it returned a new function to us. That new function is now my function with the A value filled in. So now if I say like, hey, my add 1, and I give it 10, I get 11. And the reason for that is that it partially applied this function. It filled in one of the values. And so this is a way that we can take functions and partially apply them to do some other kind of work with it. That is, and so, yeah, I'm going to leave it there with that because I don't want to like hit you with too many things all at once. So this is the very basics of like we are defining some functions. Now, what is interesting, and we're going to have to kind of keep unpacking the idea of reading type signatures. Is you see here that my function, we see its type signature is that it's a float, then this right arrow, and then a float, and then a right arrow, then float. Now, okay, let's find another function. Let my other function, I'm going to say it takes a float, yep, b float equals a plus b. Okay. Something very different is happening here, and I want you to look at the type signatures. So here on the top is we kind of have this classic function. It takes a parameter A and a parameter B, and then it returns the result of addition. Here, notice that A and B have been joined by a comma. Now, if you're watching these in order, the last video you watched was the tuple video, talking about tuples. And we know that the comma is the tupling operator. And we use the tuple to create, we use the tupling operator, the comma, to both create tuples and decompose tuples. So it's used to create tuples and decompose tuples. So I'm going to go ahead and define this. And this, if you're coming from C# as some other kind of object-oriented language, like this looks like a method. This looks like a method call or something like that. But it was probably like there probably wouldn't be a space here; it'd be right adjoined. But let's talk about this. So I can call my other function with 1.0, 2.0. I'm going to go ahead and run this. My other function, it's returning a 3. Notice that this function signature has this star in between these two floats instead of the arrow between these two floats. What is this star saying? This star is the way we write a float, the star is how we write a tuple type signature. So these two elements together, we're putting those two elements together with this star to indicate like, hey, this is a tuple of two floats. And if I, and I'm going to declare like a tuple alias. So type my tuple alias is equal to float star float. And we have just defined my tuple alias. Okay, it's saying it's not used, but like this is a type declaration. My tuple alias is saying like, hey, this is the same as a float tupled with another float. We could also say like, hey, a float and an int. But the important bit is here is this star is indicating like the values on either side are tupled together. That's what this type signature here is saying. So the mental kind of leap I'm wanting you to make is when you see this, oh man, how do I do this? Okay, I'm going to declare yet another one. So let another function, and I'm going to make my tuple alias equivalent and saying, hey, my input, and I'm going to put in the type I'm expecting, my tuple alias equal. And now notice that the type signature of these two functions is the same because my tuple alias is a type alias for a float tupled with another float. This is basically destructuring a tuple that you have passed in. Because when we called this function, this is essentially giving my other function a tuple as its argument. And so what I'm wanting you to see is like another way of looking at this is like, oh, this is a tuple deconstruction happening here. And so let my input equal, I'm going to do 2.0, 3.0. So my input is a tuple of a float and a float. And I now could potentially, and I'm just going to say this is just going to return 1, just for kicks. I'm not actually going to do anything with the input. I could call another function with my input. Oh, I should probably complete the name function. And I should also like spell that correctly too. I'm calling another function, which is expecting this my tuple alias with a float tuple. It has the same kind of structure, but here I'm not decomposing the tuple, but here in this function, I am essentially decomposing the tuple. So and my apologies if that was kind of like a weird kind of detour, but it kind of gets at something deep in the language. When you see like type, arrow, type, arrow, type, it is saying like, hey, I have this function, I'm going to take a value, and then I'm going to take another value, and then finally I'm going to like do something with it. Versus this type star type, this is a tuple, and so this is, you can think of this as like, hey, I'm thinking about like, hey, I'm passing in A, I'm passing in B, or you could say like, well, I'm passing in a tuple, and I'm going to deconstruct it into A, which is a float, and B, which is a float. So really functions and tuples have this very interesting interplay between them. So a lot of the time with functions, you're going to see it written out like this. But at the same time, you could write functions like this, but I kind of refer to this as the tupled form of the argument, where you're saying like, hey, you have to pass in all the values at the same time. So which one should I prefer? This one. Almost every time you want to do this. And this is because partially applying functions is, again, like a really core tool in our F# toolkit. But you will also see this at times much more often with methods on classes. But I want you to kind of see the interplay of tuples and functions and how they kind of work together. And really, this is just the deconstructing of a tuple. That is what is actually going on here. So what else do we need to know about functions? Well, the cool thing that you will see about functions sometimes is sometimes you will have a function that takes another function as a parameter. And I will illustrate that. Scratch that. I'm going to stop for now. I'm already at 19 minutes and I feel like that may have been like a little bit too much. So I'm going to let that stew in your mind a little bit. Please let me know in the comments if that was clear or if that was confusing or if you need me to work through more examples. But this idea of functions and being able to deconstruct tuples and functions and just how to read a function signature is a really important thing. And so we will probably continue to revisit functions for a few more videos to kind of unpack more of it. But I wanted to get that across early because it was a real aha moment for me as I was writing F# code. So thank you very, very much for spending some time with me. Please let me know what it is that you would like me to dive depth on to explain to you. Thank you very much and have a great day.